So you've done some research looking at how people explore objects when they try to figure out what an object is and they can't use vision or other cues, and they have to rely on their sense of touch. How does that work? How do you classify those things?
Well, Susan Lederman and I worked together on this going back quite a few years, and it was a sort of eureka moment when we actually realized how systematically people explore in relation to what they're trying to find out. So think, for example, if someone asked you, well, is this silk scarf really smooth? What do you think you would do?
I would probably hold it in one hand and slide the other hand over it like that.
That's right, and it's that sliding that turns out to be really important. In order to sense how rough or smooth something is, people typically slide it between their skin and the surface that they're judging. And we called that lateral motion. And we discovered some other regularities. For example, when people want to know how heavy an object is, they don't slide their fingers over it, but rather they pick it up, and usually they do some rotation around a joint with it. Mm-hmm. When people want to know how soft something is, or conversely how hard it is, they put pressure against it, against some sort of resisting force. So they may twist it, they may push into it, they may grasp it in their hand really hard, but they're doing something that puts force on the object. So Susan and I ended up cataloging 6 or so of these so-called exploratory procedures in relation to fundamental properties of objects. And when we pointed them out, I think some people said, well, yes, my grandmother would know that, which is sometimes we always use as a litmus test to see whether we've discovered something new in science. But I think at the same time it wasn't something that ever had been pointed out. And once it was recognized, it generated a lot of interest in the touch community, because in fact these exploratory movements were so repeatable, so reliable. People just had to ask why. And they also occur in animals. So monkeys will do the same kinds of exploration. The sweeping of whiskers in seals and mice has a similar function. So it turns out that in fact the regularities of exploration are one of the very interesting phenomena of touch.
And do you think that that has developed based on the information you can gather by doing particular motions like that with the particular sensors that you have in your skin, and we have just become optimal at how we perceive these objects by using these kind of exploratory procedures?
That's right. When you really look at exploratory procedures, you realize that they're actually in there to create an optimal input into some algorithm that the brain is using to compute the property. So take, for example, this lateral motion that you do when you're sweeping the silk scarf to find out how soft it is. What you're picking up, depending on the density of the elements in the scarf, so I don't want to get too technical here, but say that your scarf is a sort of fairly coarse scarf and you sweep your fingers around it, you say, this is not quite the quality of silk that I wanted, it's a little coarse. What's happening there is that receptors under the skin pick up the spatial pattern of the raised elements in the scarf, and they create a sort of instantaneous picture of them, and they see how variable the protrusions in the surface are. And that is, in fact, the input to the algorithm in the brain. It actually uses that variability to come up with a sense of surface roughness. Now, you might ask, well, why do I have to sweep my hand? Why can't I push my hand down on the scarf? And it turns out that those receptors get much more excited with lateral forces than they do with normal forces. So you can say we're a slave to how these receptors developed, and they like lateral forces, and we want the information they convey, then we're going to give them the information that they want. And therefore, that's why we sweep our hand. And a similar story can be told for each of the exploratory procedures. It's like a marriage between the receptors and what the brain needs as information in order to compute the property.
We have a couple of objects here. Why don't we explore those haptically?
Okay, why don't you pick up that object there? And I'll ask you some questions about it, and maybe you should close your eyes so that we can get your sense of touch doing the work for you.
Okay.
All right, suppose I asked you to tell me just how rough it feels to you, if you had to give it a number that indicates the roughness of that surface.
Yeah, well, this is very rough.
So what's your number?
On a scale from 0 to 10, maybe
You don't have
9.
to stick. You don't have to stick with 0 to 10 even. Okay, so now I'll ask you a slightly different question. What do you think is the height of the highest element on that surface?
It's maybe half an inch.
Uh,
3/4 of an inch.
The single element. Can you find it?
Single element?
Yeah. Ah, very good. Now you're doing something quite different with your hands.
Yeah, it might be a 1/4 inch to half an inch.
Okay, that's what we call enclosure. Now I'll ask you, what would you say is the shape of the whole block that you're? Is it more trapezoidal, or perhaps is it more rectangular?
I would say it's trapezoidal.
Okay, you're doing a combination there of enclosing and contour following. So I'll ask you one more question, and I'll say, is the back of it softer than the front of it?
Well, I already touched the back, and yeah, it feels much softer. But I'll do it again. Yeah, this is very soft.
Okay, so you're now doing a textural judgment on the back. So let me try one more thing, which is it very compliant, or do you seem to just go straight through to the rock on the other side? Ah.
Well, it gives a little bit, but that's only the first 1/16 of an inch, let's say. And then
All right,
it's all
now
hard.
I'll ask you how much it weighs.
Weighs probably 250 grams.
Okay, I think that we've shown that you explored very differently, and you indeed did the kind of dedicated exploration that we expect to see.
Well, that's very cool.
As long as we're doing object exploration here, there's another point I'd like to get across, and that's the difference between how well the sense of touch gives us information about the properties of real three-dimensional objects that we can explore with all these wonderful procedures, and how badly it does, on the other hand, in telling us about two-dimensional objects. So I happen to have brought with me some displays, and excuse me, I think I will test you on one of them.
So I
And
should
I'm
close
gonna
my eyes.
You should close your eyes, and I'm going to try to hold this up so that the camera can see it, so that your viewers know what it is. And then I'm going to ask you to explore it with your hands and tell me what you think it is. Are you ready?
Yes.
All right.
So this is raised.
Yes,
here's
this is a kind of Xerox that blind people use. That's all of the lines that would be on a black and white drawing are actually done with raised lines.
Okay. So here's something long and narrow with parallel lines. And then goes into something that's round, kind of. Maybe kind of a spoon or a big lollipop or something like that.
That's very good. You can open your eyes and take a look at it.
Oh, okay. So I got the general shape of it, but none of the finer contours or the perspectiveness of it.
Particularly the three-dimensionality. So we find that people are in fact very poor at recognizing these raised two-dimensional line drawings, and it really contrasts enormously. If I were to put a real pot in your hand, you would instantly know that it was a pot.
Okay. Well, thank you very much.